What's a normal fault? You're going to find out. You're going to know all about faults. Does this look normal? Well, it is. It's a normal fault. Okay, stress is the amount of force you put on a given material. So like if you put your face together, you're putting an amount of stress on it. That's the force that's putting on it. So stress is the amount of force putting on a given material. Then we got to look up what the rock's made of, okay? So certain rocks are going to bend, certain rocks aren't. Temperature and the amount of pressure determine how much stress a rock can handle before it breaks. So if you got a rock like this and it's made of this material, it breaks pretty easy. Okay, if you got a rock like this, made of this material, it doesn't break as easy. So it handles more stress. There's two types of stress. Stress I get from you and a stress I get from home. No, the stresses are compression, squeeze together, come together, convergent, begins with C, stress, push together, okay? And then the other type is tension. You're pulling it apart, you're ripping it apart, okay? So two types, come together, pull apart. Those are the two types of stress. Deformation is a change in the shape of a rock from stress, and you can see here where the change occurred. The change of the rock is right there, and that's basically from stress. That's called deformation.
These giant gashes in the Earth are reminders of our planet's awesome power. They are fault lines, fractures in the Earth's crust where huge slabs of rock slowly grind past each other.
Like that.
Most faults we can't see, but here in California, the San Andreas Fault is visible at the surface.
You can't have an earthquake without a fault. And I'm standing right now on what is perhaps the most famous fault in the world, the San Andreas Fault, that extends from Mexico down south, way up to Oregon in the north. This is one of the few places in the world where you can stand with one foot on one tectonic plate and one on another. In other words, this ground here is attached to New York and Iceland. The ground here is attached to Hawaii and Japan.
The San Andreas Fault sits on the boundary between the North American and Pacific plates. It's called a strike-slip fault, a place where two plates collide and try to slip past each other. As these plates move or creep in different directions, sometimes they get stuck. The longer they stay stuck, the more tension builds and the bigger the eventual quake. In other places, the plates move smoothly past each other. These areas buckle as the Earth shifts. The changes are subtle. Roger Billam keeps track of these changes with his creep meter, a device that measures movement along the fault. A computer collects data every minute for a year. This jump in the graph tells him the Earth shifted about 5 millimeters in a couple of hours. A small shift like this can have huge consequences for us.
That might not seem much, 5 millimeters, but it's affecting a long section of the fault, maybe 5 miles long, involving millions of tons of rock. Now, it really doesn't matter here. This is a nice sort of field, there aren't any people. But further north, this creep process and the things that are happening beneath the Earth are far more sinister.
The San Andreas Fault and its branches trigger more than 10,000 quakes a year. Sometimes the results are devastating. Just ask the people of Los Angeles or San Francisco. Over the last 2 decades, major quakes rocked both of these cities. Life goes on, but the risk remains. In an area this active, the next violent tremor could happen at any time.
Okay, a fault is nothing more than a crack in the Earth's surface, okay? So you got the Earth's surface, it's going together, and next thing you know, it cracks, and that's it. And one side is going to move, okay? And compared to the other, that's all that is. And there's two parts to a fault, okay? You've got the footwall, which is the side of the fault you could look like you could run up on, and that's this one. You could run right up there. That's the footwall. And the other side, this side, is a hanging fault. And the hanging wall is where it's very steep, and it looks like you could hang from it right there. So those are the two parts of the fault.
It's weird because when you're climbing, you get into this numb zone. There's a different state for everyone, but really it's like you're one.
She was one with the wall. She was on the hanging wall. She was hanging. Get it? Okay, there's three types of faults. You got two types of stress, compression, tension. You got two types of faults, the wall. They look like that. Footwall, hanging wall, and now you got three types of faults. And the first one is a normal fault. That's when the hanging wall moves in relation to the footwall. So what happens is you have like that, and it just moves away and it slides down. When you move away, you slide down. Okay? So now it's caused by tension, okay? And they're being pulled apart. Okay? So the tension, it pulls it apart, and something has to slide down. If you pull these apart, they got to go somewhere, and this one slides down. That's a normal fault. And it looks pretty much like this. So you can see that this section of rock up here was connected to this section of rock down there. It slid down, and when they pulled apart, that's a normal fault. The next type is a reverse fault. And a reverse fault, that's when they're pushed together. So now we have two pieces of rock, they're pushed together, and this one goes over it. Oh my gosh, it's up above it. So now you have a piece of rock above it. It's called compression. It's pushed up like that. Pushed and it goes up. And that's a reverse fault. And you can see that you've got the hanging section right there above it. And in this case, you can clearly see that they started there, and then the next thing you know, it pushed, and now that piece is way up there that used to be right there. And the last type is a strike slip, and you know this because of the transform fault. They're together and they're just sliding by each other, and that's where you get big earthquakes, big chunks of rock going against each other, and they move left to right, and the other one moves to the other side. And this is what's happening with the San Andreas Fault in Los Angeles and the rest of the United States. They're moving. Strike slip, again, this side's going this way, this side's going that way. Now, these all should look familiar like before. That's going this way, and the other one's going that way. So that's a strike slip, their fault. You can see the road was here, should have been right up there, and now it's over here somewhere. So it's not quite the same place. And that would be a reverse fault, pushed up over it. Here we have a normal fault, slid down. Tension pulled them apart. Strike slip, notice the fence was together right there, and now it's going to end up right up there. So that's the strike slip fault. Okay, there's three types of faults, and here they are, and they're easy. Okay, it's just the same thing as the plate boundaries. Compression, come together, tension, pull apart, diverge, and then strike slip, same thing as transform boundary. So they just same type of thing, only now the rock is moving and you're going to see it. So first one, you should be identifying that. It's not normal because now it's above it, so it's a compression pushed against it, and it's a reverse fault. The next one, they're going by each other. You can see where the road should have been by the dots, and that's the strike slip fault. Okay, and the last one is they're pulled apart, tension, so one slides down, and that's normal. So that's the normal fault. This is what happens when you have faults in the water. This was Japan a couple years ago. Huge earthquake underwater caused a tsunami. Very powerful water. Not a Japanese movie where those are toys. Those are actual real cars. Real boats. Moving everything. The rock slips, causes the water to go and take off in a big wave, and there it is. That's powerful. The tsunami is the big waves caused by earthquakes, plate movements under the water.